Now let's write down our next heading, reactions of benzene. Reactions of benzene. Now there's going to be tons of reactions there, and as I told you, rest be assured, because the examiner cannot give you a new equation in the exam. So that's why I said kind of, but it's not heavy duty memorizing. It's like very comfortable, very sweet. Okay. So don't get overwhelmed. It's just very simple reactions. Keep it very easy in your head. This is the good stuff of the exam area for you. Okay, so let's have a look at our first reaction. This is the hydrogenation. Okay, so let's have a look at hydrogenation. So I'm going to add hydrogen, and we're only talking specifically of benzene. Don't forget that's the SKF now. Okay, this circle inside represents that the pi electrons are constantly shifting their position. The pi, this is the huge big pi bond which is literally spread on all the 6 carbon atoms. Okay, so that's the SKF now of the modern structure of benzene. Not like Kekula. Remember, Kekula said like this. Don't forget, Kekula said like this. He said no, the pi double bonds are specifically at one place. But we know that's not possible. Okay? We did all that in the last class. Okay, I need to add hydrogenation. It's pretty straightforward, really, isn't it? I mean, that's benzene, and I'm just going to add hydrogen to it. So obviously, I mean, I need 3 moles of hydrogen, because everything, all the double bonds, everything will be attacked and is also changing into, this is cyclohexane. So that is C6H12. Guys, don't forget, this is always remember, sometimes I see some senior students, they don't pay attention to these, like sometimes they get confused into, okay, who is this? So remember, that's a CH. I'm just writing a few of these just to make sure that you understand that's a CH, okay? Okay, this is all CH here. But then when you come to cyclohexane, you must remember that is CH2, because carbon is supposed to, okay guys, you should not do that in the exam. I'm just trying to make you understand how things are. Okay, so that's what it is. Is that okay? This is just for your reference. I don't want to write it because that's not the correct thing to do. But just to make you understand, each corner in a benzene, SKF, is CH, and each corner in a cyclohexane is a CH2. So maybe I'll just mention like this, that this is CH and this is CH2. Okay, just to be sure. Okay, good. I need some conditions for this one. Some reactions have conditions, and this is where memorizing comes very useful, and you got to memorize it. Okay, so you have to say, I need nickel catalyst. This is where the memorizing is. These are all direct questions in the exam. So you need nickel catalyst, and you want heat under pressure. Heat under pressure. Okay, so that's the reaction conditions. They will ask you who's the reagent. So hydrogen becomes the reagent. Sometimes they will say, okay, who's the reagent? What's the reaction condition? Who's the reagent means who you reacting with? I'm reacting with hydrogen, so that's my reagent. What's the catalyst here? That's the nickel catalyst, and that's the conditions there. Okay, so do you have any questions on this one? Give me yes or no. I'm done with hydrogenation. Do you have any questions for me here? Easy? Can we move on? Okay. Let's have a look at combustion reaction. So combustion reaction, I'm literally going to burn benzene. Okay. So when I burn benzene, it's a very simple, it's a hydrocarbon, and as every hydrocarbon, it burns very easily to change CO into CO2 plus H2O. Okay. It produces a smoky flame. It produces a smoky flame. Okay, so we need to balance this equation as well. So I need to put here 6 because I have 6 carbons there. Because I have 6 hydrogens there, so I need to put here 3. And then I'm going to add up all my oxygen on the right side. So 6 times 2, 12. 12 plus 3, 15. So I can do 15 by 2, or I can do 7, 1 by 2. So that's also like 15 by 2. So 15 by 2 is 7.5. Okay, so any of that is fine. You don't have to mention state symbols in these equations. Okay, let's have a look at our third equation, that's bromination. Or maybe we can just go to our next page. Guys, do you have any questions? If you have no questions at this point of time, could you just mention NQ? So we can go to our next page. Please feel free to ask questions anytime you want to use the mic or whatever. Okay, so let's do bromination because we're going to talk of bromination. Now, when I say bromination, I'm not talking of electrophilic addition that we just now agreed at the beginning of the class. That's difficult. But we did agree on one thing, that benzene can undergo electrophilic substitution with bromine. It can't undergo electrophilic addition with bromine because it doesn't have the localized high electron density area, right? So let's have a look at, so how do we do bromination of benzene? So we do that under the category of electrophilic. We'll talk about the mechanism soon, don't worry. Electrophilic substitution. So what happens here? In fact, most reactions of benzene are electrophilic substitution. So, okay, just to make things easy for you, I'll write a comment and see if that helps you. In electrophilic substitution, the H of the benzene ring is replaced. So this is the main idea. Whenever you do electrophilic substitution, just kick out a hydrogen from benzene. That's it. And whatever you're trying to put in its place, you will do. It's a substitution, right? H goes out, something else comes in. That's it. Okay, so that probably will be some good stuff, easy stuff in your mind. Okay, so let's do some reaction. So I have here benzene, and I'm reacting this with bromine aqueous. Now remember, we were discussing something here, that it needs a halogen carrier for this reaction to actually happen. And these are my options. I have aluminium chloride as an option or aluminium bromide as an option. Well, what do you think? I mean, I want to work with bromine, so obviously I must select AlBr3 now. Okay, so what I'm going to do is, I think I should write that. So my conditions, okay, they'll ask you conditions. So my catalyst is AlBr3. That's my halogen carrier, and I must heat under reflux. Okay, heat under reflux. You'll probably hear this word a lot. Reflux, heat under reflux. So, you know, if you can have time, just Google it. You will see a device which is completely closed. And we do heat under reflux, particularly when we're dealing with extremely high volatile liquids. I mean, you understand, you can't really heat a high volatile liquid in an open beaker. I mean, that will be disastrous, isn't it? Okay, so you want to close it down and you want to ensure that no reactants are lost in your heating process. So that's why we do heat under reflux. Okay, so go online, just have a quick look at what does it actually look like. So it's a small, it's almost like a volumetric flask kind of shape. Okay, that's all. We just carry out in a closed container this heating, but of course, not a container which is going to allow a lot of vapor pressure to be built up. Okay, so sorry, not aqueous, sorry, big mistake. Bromine has to be in the form of liquid, and I need to make sure that you are absolutely clear here, because later on we'll be discussing a reaction of phenol. I'll be comparing phenol with benzene, and then you will see the difference. So remember, bromine has to be in liquid state here. So we need bromine in liquid state, and we also need a catalyst AlBr3. We need heat under reflux, a lot of things required. And I can just, you know, you might find the Br coming in here or here, doesn't matter, wherever it is position number one really. Okay, so I can put the Br here, I can put the Br here, absolutely no issues. Okay, so it's completely fine. So I just took out one H, remember, one H from the ring has gone, and that one H connects with the Br which is left over here to form the HBr, and this is C6H5Br. Okay, so this is bromobenzene. This is bromobenzene. There you go. Okay, Done. And of course, the bromine liquid will get decolorized. It will get decolorized. And done. Okay, simple reaction. Do you have any questions for me? I'm done here. This is not the mechanism, we're just doing the reactions. If you have any questions, let me know. If you have no questions, could you please type NQ? No questions, please. Bromination of benzene. Okay, so don't forget, this is my reagent. If they ask you who's the reagent, that's the reagent, and the conditions I've already mentioned here. I know it's memorizing, but memorizing is good because they will ask you only this in the exam. Good for you. No? Okay. Let's have a look at, so how do we do nitration of benzene? Now remember, benzene loves to do electrophilic substitution. It's more easy for it. Okay, so it's very happy to kick out a H of the benzene structure, and so I want to do nitration of benzene, and it does the same thing. It just kicks out. We are still doing, remember, electrophilic substitution. So let me just write this down. The moment I say electrophilic substitution, don't forget, it means the H of the benzene ring is going to get kicked out and replaced by whoever you're trying to bring in. Okay, so that's the general idea. First of all, let's be very clear because this is very important. Reagent. So who is my reagent here? The reagent is concentrated HNO3. HNO3. Okay, I need concentrated HNO3 and I also need concentrated H2SO4. So it's actually like a mixture of these two. Okay, so they are two, both of them are mixed together. And concentrate H2SO4, that's the one who's going to act as the catalyst in this reaction. Okay, and that is my reagent. That's the main reagent who's going to pick up the role there. Okay, so this is reagent and conditions. And what else do we need? We need temperature. So we need to keep the temperature steady between 50 degrees Celsius to 60 degrees Celsius. So that's the temperature. And if they ask you what's the name of the reaction, don't forget, this is the name of the reaction. Name of reaction. So if they ask you what's the name of reaction, electrophilic substitution. Don't say nitration. Okay. Whenever they say name of reaction, the examiner always expects you to use the reaction mechanism name, not the general name. Bromination is a general name. Electrophilic substitution is the mechanism name. Okay. So anytime if someone says what's the name of this reaction, stick to the mechanism name all the time. Okay, good. So we got everything now. We know who's the reagent, concentrated nitric acid, who's my catalyst, concentrated H2SO4, and mechanism I will teach you a bit later, as I said, and that's my temperature there. Okay, good. So the reaction is pretty straightforward. So we know it's electrophilic substitution, which means one of the hydrogen is going to get kicked out. Okay, so when you write the reactions, no one will expect you to write the state symbol, so don't worry about it. Okay, just for your memorizing sake, I'm just writing here on the arrow. You don't have to do this in the exam. You don't have, normally they'll ask you as a separate comment who's the reagent, conditions, and so on. Okay, so as expected, one of the hydrogen gets kicked out. Okay, so I'm just taking out the hydrogen from there. I remember I can take out from anywhere. And I'm doing nitration. So that's how the nitro group, the NO2, the nitro group comes in. And of course, I will get the H2O as my secondary product. Okay, I'm done. All right, I'm waiting for you if you have any questions. So we've done bromination of benzene. I need liquid bromine and heat under reflux and AlBr3. Nitration of benzene requires concentrated nitric acid in the presence of concentrated H2SO4 and the specific temperatures. Waiting for any questions, let me know if you have any. So let's have a look at our next one, which is now sulfonation. Remember, everything is now going towards electrophilic substitution. So this is reaction number 5. Sulfonation of benzene. We can probably use pH as well, but the new spellings. Okay. So sulfonation. So who is my reagent for this reaction? So for this reaction, I need fuming sulfuric acid, which obviously is pretty highly concentrated. Fuming H2SO4, literally. Okay. So, and I need to keep the temperature steady at 40 degrees Celsius, and I'm going to heat for this is also required because this reaction is not an instant reaction. It needs some time. Heat for 20 to 30 minutes. Okay, so you got to remember the reagent conditions. So that's fuming sulfuric acid. Temperature, keep it steady at 40, but you got to do this for 20 to 30 minutes for the reaction actually to take place. Okay, so let's see what is this reaction about. This is the reaction which puts the SO3H group on the benzene ring. So that's my reagent, H2SO4, fuming sulfuric acid. It is concentrated. And then when we say fuming sulfuric acid, guys, it just means when you open the reagent bottle, it kind of interacts with the air and you might see misty white fumes coming out. So fuming hydrochloric acid, fuming sulfuric acid. It just gives you an indication these are like pretty concentrated acids. Okay, and then that's the SO3H group. That's the group which is coming in. Okay, so that comes from the H2SO4. And don't forget, one H was knocked out from benzene. It's still electrophilic substitution. Don't forget. This is still electrophilic substitution, which means one of the hydrogen is getting knocked out, replaced by whoever is coming in. So that gives me my secondary product, the H2O. Okay, questions if you have any. We are just doing the reaction, we are not doing the mechanism. This is called benzene sulfonic acid. Benzene sulfonic acid. Guys, if there's any question, this would be a good time. Any questions so far? Okay. Reaction number 6. Okay, now this one is pretty popular when it comes to exam. Easy reaction, they follow the same trend, but you'll find them very, very popular among the examiners, and you will hear about this so many times. Okay, so this is a Friedel alkylation. Have you heard these names? Are you guys ahead in this lesson in your schools, or are we ahead? What's the status if somebody can update me? Are we ahead or is the school ahead? Friedel alkylation. Where did the extra H come from? Hold on. Are we talking of the SO3H? One H came, so we need to balance the equation. I didn't balance it properly. Could we balance it? Could we balance the equation? This is C6H5 SO3H. Guys, can someone check the balancing, please? My carbons looks to be okay. Hydrogen, I have 6 plus 2, 8. 6 plus 2, 8. H is balanced, Baba. I have 5 hydrogens here and 1 here. So that's 6 hydrogen plus 2, 8 hydrogens. I have 8 hydrogens here and I have 8 hydrogens here. Is that okay? No, 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 no. We can't. That's see, this is the ring. Okay, guys, don't forget. This is benzene, C6H6. This is phenyl. This is C6H5. This is called phenyl. It's the so-called the aryl group. This is the aryl group. Like we have alkyl group coming from alkanes. So we have aryl group coming from the benzene, the arenes. Is that okay? So that's C6H5 and it stays as C6H5. Okay, so you can't reorient it. That's going to mess up these structures, your writing style. Okay, are we good? So just to be on the safe side, you see how I wrote this? That's a C6H5 and then a Br. Okay, so probably here as well. That's a C6H5 and then I'm going to write the NO2. And this is called nitrobenzene. This is nitrobenzene. Yes, hope that's okay now. Okay, so Friedel alkylation. So let's do one thing. I'm going to give you some comments which probably will straight away tell you what exactly happens here. So that makes your learning process also much more easier. Okay, so just give me a second. Okay. Okay, so when it comes to Friedel alkylation, this is done. It is electrophilic substitution. So let's put that away. Electrophilic substitution, which means which means I'm going to kick out a hydrogen and I'm going to bring somebody else, right? So now you got the idea how this works. Friedel alkylation is to introduce the R group. R group. Now, what is this R group? R group is called the alkyl group into the benzene. Okay, so let me give you some example. Okay, so examples of the R group, which I think you should already know coming from the previous units. Example, I have CH3, that's called methyl group. CH2, CH3, which could be written as C2H5. And this is not just a dash, this is the empty bond which they are going to connect to the ring. This is called the ethyl group. Are you aware of these things? Can you just quickly give me yes or no? So that's a CH2, CH2, CH3, which can be written as a C3H7. And these are called propyl group. Okay, these are called the R groups. Give me yes or no if you're okay with what examples of R group, what alkyl group actually means. Okay, so I just want to put any of these onto the benzene ring. That's my ultimate idea. That's what happens in Friedel alkylation, to honor the name of the scientist who gave this reaction and its mechanism. So if you're ready, let's go to our next page. Let's do the reaction itself. Reaction is pretty straightforward. No. C2H6 is called ethane. And thank you so much, guys. You're asking questions. That's beautiful. Always a good sign to see. Okay, that's ethane. Okay. And if I take out a hydrogen from there, I get C2H5. That's ethyl. Is that okay now? Did you get it? Okay, got it? Okay, good. So the same goes for propane. Basically, okay, this is the format I probably might have given you. Take any alkane, knock out a hydrogen, you get an alkyl. How about that? Does this make sense? Okay, so take any alkane. You take propane, kick out a hydrogen, you get propyl. You take butane, kick out a hydrogen, you get butyl. Got the idea? That's how alkyl groups are made. Okay, good. So let's go to our next page and let's see what reagent do we need. What should be the reagent and conditions? Examiners love to ask these questions. Okay, they'll ask you, how do I convert this into that? So who's my reagent? What's the condition in this reaction? So I need somebody to give me the CH3, or maybe let's say I want to work with CH3. Okay, so remember there are so many R groups. I can work with CH3, I can work with ethyl, I can work with propyl, I can do anything, right? So I need somebody to give me that. Okay, so let's see who is that. So reagent conditions is we can work with halogen alkane. Halogen alkane. Halogen alkane, like I can work with CH3Cl. I can work with CH3Br. I like any halogen, whichever I want. If I want to put Cl, I'll use CH3Cl. Okay, but I can use any halogen alkane. but my main intention is to put this R group. You understand? I can work with C2H5Cl. I want to put this group on the benzene ring. Okay, anything fancy, C3H7Cl. I want to put this group on the benzene ring. So these are my halogen alkanes. Focus on the R group. So these guys actually, even the alcohol can be used. Even they can give you the R group. Okay, but let's stick with our this reaction. Even also alcohol. Also alcohols. I can even use alcohols. I can even use this. See, even alcohol can give me this. So if I want CH3, I can use alcohol, methanol. I can use ethanol, or I can use halogen alkane. I can do whatever, whichever source I can use. Okay, so that's the reagent there. It's always good to be very clear about who's the reagent, what's the reaction condition, what's the name of the reaction. Okay, very, very important for you to always keep that. I need a catalyst. Now remember, anytime benzene does electrophilic substitution and wants to put a halogen inside, we discussed this today morning again. Okay, you want to put a halogen on the benzene ring, you need a halogen carrier to act as a catalyst. So that will now probably give you an idea that I can use AlCl3. Please memorize this. Okay, so that's my AlCl3, that's my halogen carrier. Okay, so we'll stick with that. Okay, I can use AlCl3 or I can use AlBr3. Now you got to be careful which one you select. Okay, you want to put, this is for Cl. If you want to work with Br, then you pick up this one. Okay, don't mix it up. Okay, be careful there. Let's do some equations to make sure you're okay. Let's say simple equation. Maybe you can go ahead and try. I have benzene and I want to react this with CH3Cl. So could you tell me which catalyst should I use? You see, I want to put CH3Cl because I have a Cl going on. My catalyst in this case is going to be AlCl3. Is that okay? Uh, don't we need to add an alkaline group? Um, okay, could you explain further? Because alkyl group, yes. So I need to add the alkyl group, correct? That is my alkyl group. Okay, guys, don't forget. That is my alkyl group. I want to add this on the benzene ring. Okay, so what happens now that this alkyl group is going to come on the ring. So what goes out is a hydrogen. So don't forget, it's a electrophilic substitution still going on. Okay, so I think I already mentioned that. Okay, now could you guess what will I get? So what will I get now? The CH3 goes on the ring, so I get methyl benzene. Methyl benzene. For those guys who are preparing for entrance examination, you'll probably see the word toluene, but you don't have to use for your board exams. But toluene is a common name for methyl benzene, right? So that is C6H5CH3. Once again, don't forget I was speaking a few minutes early. That's the writing style. Okay? That C6H5 cannot be changed into something else. Plus, what do you think I will get? One H gets kicked out there. That H and that Cl, that H and that Cl connects together to form the HCl. That's it. Nice and easy. We're done. Okay, questions now. Does that answer your question? I put the alkyl group on the benzene ring and I got methyl benzene. Does that answer your question? Can we do another equation? I will give you another way how this question can be asked. Okay, if you're ready, let me know. We can go to our next page. There is another way how this question can come. Don't forget that's benzene, the good old benzene there. This is your C6H6. Okay, let's do another question. Let's say a question says convert this to Okay, guys, I'm just trying to mess with your head, okay? This. That's the question. So the question says reagent plus conditions. Okay. So what is the reagent plus condition for this reaction? I want you to change this into that. And purposely examiner gives you SKF format. Could you first of all tell me what's the name of this compound which I drew here? And could you tell me the formula of this compound? That is C6H5. I'm going to be explaining the mechanism in a short while, and then you will come to know the role of AlCl3. Will that be okay? Is that okay? Without this, the reaction cannot go ahead. Is that okay, Baba? The role of AlCl3 I will explain when I teach you the mechanism of this reaction. Right now, I'm only teaching you the reactions. Is that okay? Please confirm. Just give me a few minutes. We are going to be there. Okay. So we need the AlCl3, otherwise the reaction won't happen. Okay, so I need to put this. This is C6H5, CH2, CH3, ethyl benzene. Very good. So that's the compound. So I want you to change benzene to ethyl benzene, which clearly means I want somebody to give me the ethyl group. This is the ethyl group. So who could be my reagent? This is the question. Who can be my reagent? Suggest somebody who can give me ethyl. Look at the options I gave you. I need either you can work with the halogen alkane. That's the easiest one if you want to follow. Alcohols can also give it. So I can work with halogen alkane. So does that make sense that I need CH3, CH2 and I can just do this? Give me yes or no, you understand. That's my reagent. Because I need the CH3, CH2 to go on the ring. Does that make sense? You can work with
Sir,
Cl. Yes, you can work with Br. Yeah, tell me.
if you use the alcohol one, is the catalyst also AlCl3
Yes,
or
the catalyst still
AlBr3?
remains AlCl3, but the problem, that's why I'm not mentioning alcohol much, because in mechanisms and everything, we are going to work with AlCl3 all the time. So you could, just leave that out. But alcohol can also be used, is a comment I gave you for mechanism purposes. But I will tell you how it works. But I've not seen the alcohol in your textbooks really. But Cambridge we used both, so that's what I'm saying. So you want to stick with as per yours only, so unnecessarily let's not add more information. What do you think? We'll just stick with what's easy and what's mentioned in our book, so we'll just stick with that. But just remember, R can come from alcohol, at least for entrance examinations and all. Just keep that point in mind. Okay, it can work, there is no problem. And let me just check with some past paper questions to confirm that in your schemes alcohol was given as an option. Okay, I'll get back to you on that. No, absolutely no problem, just give me a few days. When I have a time, when I'll be preparing past papers of this, I will confirm if the alcohol is also allowed in Edexcel Pearson. If it was an entrance exam question, you could say chloroethane or ethanol. It will work. Okay, so let's stick with what's in the book. Is that agreed with it by everyone, guys? Yes, no? Okay. And who's my catalyst here? So that's AlCl3. Okay. Um, is everyone comfortable with the equation? So that's basically benzene, and you react this with CH3CH2Cl, and what I will get is ethyl benzene. There you go. Plus I will get the HCl. Done. Any questions more? Friedel alkylation. Okay, here's another thing. Just for the sake of so-called confusing questions, if they give you like this, change benzene to this. Okay, now I want to change benzene into this. You don't worry about the naming. This is isopropyl. You don't have to have these names. Okay, your challenge is now can you tell me who could be the reagent and who is the catalyst? Okay, catalyst everyone agrees we'll stick to AlCl3. And if they ask you name of the reaction name. Okay, reaction name also remember anything that goes on the benzene ring, it is called electrophilic substitution. Electrophilic substitution. Okay, could you suggest um, what could be? You could try to write the name of the reagent or the formula if you can. The trick is I need this. This is my R group. Any suggestion? Who could be the reagent? The trick is to take out the R group as it is. Correct? And you know that this R group is connected here on the benzene ring. So what do you think I should just attach here? I mean, literally I'm copying it as it is. So I just have to stick. Any idea what to do? Do you think I can put a chlorine here and will it work? Can you tell me the name of this compound? Try to tell me the name of this compound. See, this can also be written this way. I mean, I'm just trying to give it a more. This is 1, 2, 3. 1, 2, 3. That's a 3-carbon chain. The chlorine is at the second position. This can be written this way. Chlorine here. Perfectly fine. It can be written drawn this way. Okay. Do you understand this is 2-chloropropane? Give me yes or no if you understand. The 2-chloropropane it is. Guys, please confirm. So basically, I have to kick out the Cl from there and stick the R group. Does that make sense? That's the R group here. That's the R
Sir,
group. Yeah.
but the thing we're attaching it, like the in the question, the thing we're attaching it to, it's not the profile group.
This is
It
not
has an
propyl. This is
extra
called
brand.
isopropyl. You don't know this name. This is not propyl.
Yeah, that's what I'm saying. So why are we gonna attach the chloropropane to it?
Say why are we attaching the?
Chloropropane to it if we want the isopropyl.
So this is not chloropropane. This is 2-chloropropane. When you say chloropropane, the Cl is at the first position. This is 2-chloropropane. If you say chloropropane, this is CH3, CH2, CH2Cl. This is going to turn benzene into this. This is propyl benzene. You see this? This is something else. But if the Cl is attached on the second carbon, now you see what's happening? Did you understand what happened? Isn't
Oh
this,
yeah, okay.
it's written this
Yeah.
way, got it? So if you put the Cl, that's a secondary halogen alkane. So that was a trick question there. So the moment you see this fancy stuff happening, that means halogen is not in the first position now. Halogen is in the second position. So I used this secondary halogen alkane. I used a 2-chloropropane. So if I remove the chlorine from the second position, I get my the R group in that, I get my R group in that format. So this is a CH3, that's a CH3, that's a CH, and that is a CH2 who actually had a Cl, but then the Cl was kicked out, correct? That Cl got kicked out. So now I have an empty bond here. Get the idea? That empty bond goes and connects to the whole thing. I hope that's correct. No, sorry. The Cl was here. Sorry. That Cl got kicked out. When that Cl got removed, from there. So this empty bond here got connected to the benzene ring. Does that make sense? That
Yeah.
Cl gets removed. Okay. So now what's left is this. Now is it okay now? Better now? That's the
Yeah.
fancy R group which I wanted to put on the benzene ring. Got it? Okay. Well, that's the Friedel-Crafts alkylation, if you have any questions for me. So we have now one more thing to left before we start mechanism, which is exactly like Friedel-Crafts alkylation. That is called Friedel-Crafts acylation. I don't have to teach you anything new. I just have to tell you a new reagent and that's it. Everything is the same. So is that okay if I just finish that as well and we can probably take a few minutes off? Is that okay? This is called Friedel-Crafts acylation. So I did Friedel-Crafts alkylation. That is reaction number 6. We are now doing the last of the reaction, Friedel-Crafts acylation, which is carbon copy of everything what I spoke for the last 3 minutes. But only difference now, my reagent is different and this point is going to get changed. Friedel-Crafts alkylation was to introduce the alkyl group. The Friedel-Crafts alkylation was to introduce that. The Friedel-Crafts acylation is to introduce the RCO group. Okay, so sorry. It'll just take just a few minutes. It won't take that much time and we can take a short break if you want. So this is now the last of the reaction, Friedel-Crafts acylation, which also follows exactly like electrophilic substitution, because one H of the ring is going to be replaced by somebody else. So electrophilic substitution. Electrophilic substitution. Okay. So this is to introduce the RCO group. There you go. That's it. Just remember this. This is to introduce the RCO group into the benzene. That's the main challenge. So I need somebody who can give me this. You already know what R means. R is the alkyl group. Okay. So the best reagent to work with is acyl chlorides. Acyl chlorides. Examples of acyl chlorides. They are, okay, first understand what acyl chlorides look like. This is acyl chloride. You see this? Okay, no, we don't take acyl bromide or iodide, specifically acyl chloride. They are named as alkane oil chloride. That's how we name them. Alkanoyl chloride, oil chloride. That's the naming format. So don't forget that. So let's try out a few examples. Now, instead of R, that's the R group. You know who this is. So CH3 COCl. I'm just trying to open up the display here just to make you aware of what an acyl chloride looks like. Of course, this will be written as CH3COCl for the purpose of the exams. Okay, so the moment you see a COCl, you're looking at an acyl chloride. So how do I name this? I have two carbon. That's my carbon number 1. That's my carbon number 2. I have two carbons there. So I'm going to say ethane. I'm just using the format here. Ethane, and just add oil chloride. Ethanoyl chloride. That's the naming format. Okay, we're just getting familiar with some names. So another example, CH3CH2COCl. So how do I name this one then? I have like, how many carbons do I have? I have carbon number 1, that's always carbon number 1. Carbon number 2, carbon number 3, I have 3 of them. So I'm going to call this propane oil chloride. Okay, so now you got the idea how this goes. Okay, don't forget the very popular the benzene. Even benzene, they have COCl. There you go. Good to know this one. So this is classic C6H5COCl. Okay, this is called benzoyl chloride. Good to feel familiar with these names. Okay, good. So now you got a lot of reagents there. Any of these guys can work. Okay, so ultimately it depends on what kind of RCO you want to introduce. That's the RCO. This entire thing is the RCO. Don't forget. That's the RCO. Okay. Now let's do some questions to understand how this goes. Let's do Friedel acylation. So I want to change this. Okay. So you, of course, the catalyst once again stays the same. Is AlCl3. The halogen carrier stays the same. No change there. Okay. So could you suggest the reagent to change benzene into, for example, this compound, COCH3. Now this is named as phenyl ethane on. Notice carefully, it's a ketone. Why? Because of that. That's a ketone, isn't it? Yeah, CO, right? RCOR. Isn't that a ketone? You've done ketones before. Okay, so that's the ketone there. Okay, so that's the phenyl, and that's why is it ethanol? Because there are 2 carbons. That's why it's ethanol. So we say phenyl ethanol. Okay, so what reagent do you suggest? Of course, my catalyst still remains AlCl3. It's electrophilic substitution reaction. Guys, waiting for you to tell me what reagent will give me this.
Sir,
Yes.
don't we want to add a COCl?
Say again, please.
Don't we want to add a COCl? Like an acyl group?
Yeah, I mean, I need somebody to give who can give me COCH3, correct?
So does it not? Do we not add a chloride to it?
Yeah, that's why I'm waiting for you to tell me give me the formula of the reagent. What do you think? Are you suggesting CH3COCl?
Yeah, no, but I mean, like the product doesn't it have to have a chlorine in it?
No. Don't forget who's coming out from the ring. Okay, let me make it more clear here. Yeah, look at that. That's the bit which is going to go on the ring, correct? And don't forget it's electrophilic substitution. So who goes out? Guess. H goes out. So what do you think is going to happen now? Guess what happens?
So then why in the diagram did you put it as? So then why in the diagram did you put it as C6H5COCl?
Okay, which one are you talking about?
In the first diagram. The one that's at the top.
The first one. I was giving you different
The
examples of the
benzoyl
reagent.
chloride.
I was giving you different examples of reagent. I can work with CH3COCl. I can work with C6H5COCl. It depends on what I want to put on the benzene ring. If I want to put CH3CO, so I need
Oh, okay.
CH3COCl. It depends on what I want to put. I want to put CH3CO. Remember, that is my RCO, correct? Isn't this my RCO? My R is the CH3 and the CO, correct? So my R happens to be the CH3 here. So I just have to, okay, I need somebody like who can give me CH3CO. Obviously, I need an acid chloride. So the only option for you to stick there. Let me give you another question. Maybe this will help you to clear your doubt. Can I give you another question? and it is still called electrophilic substitution. What if I say I want you to change benzene into, hold on, just give me a second. Can I go to my next page? Okay, try this one. Okay, here's a question for you. Okay, so I want to convert benzene into this compound. Okay, so I'm just opening, it doesn't matter where I put, okay, so don't get too, hold on. It doesn't matter how I draw this, okay, so there you go. There you go. Okay, now this compound what I gave you is phenyl benzone, benzenon, sorry, benzenon, phenyl benzenon. Now what? What could be the reagent? Catalyst, we agree, is AlCl3. Now, what exactly do I want to put on the benzene ring? I want to put this on the benzene ring, correct? This is my RCO. I want to put this on the benzene ring. So suggest me the reagent now. Could you maybe open the mic and speak? What could be a good reagent for this reaction? Anyone who
The
can give me, yeah.
benzoyl chloride.
So let's say, okay, I'm just going to draw it also the same way, so that's easier for you to connect. So I need someone to give me this, correct? So the only logical choice is this one because I need an acid chloride, no? Okay, tell me if that makes sense to you. And how do I write this thing down? So this is C6H5COCl. This is benzoyl chloride. Okay, everyone on a scale of 0 to 10, where are you on this one? Like you understand that I need to do this reaction. So let's say I want to write it this way. So that's the benzene, and I want to react this with this compound, COCl. This is where the reaction is happening. Okay, so now what happens? So one H of this benzene gets kicked out, and the Cl of that gets kicked out. So that CO becomes the bridge. So that CO becomes the bridge. And then I'm just going to connect the second ring onto it. And then I have HCl. That's it. Nice and easy. So that's a 6C6H5 CO C6H5 diphenyl ketone, or as we say. No, Baba, no. Yeah. R group goes for alkylation. This is acylation. Here RCO will go. Yeah, please confirm. Acylation means RCO will go. Alkylation means only R will go. Did you see the difference? Give me yes or no. Got it? So if you talk of alkylation, you will only put the R group. Got it? So the moment you say acylation, then you are putting the RCO. Sorry, you're putting the RCO. Everything is the same. The mechanism is same. The catalyst is same. Everything is the same. Okay, only playing with R, alkylation. If you're doing RCO, acylation. That's the difference between the two. Got it, guys? Good. Anybody else? Any questions? Okay, just to summarize. Okay, just to summarize this, just to be sure that everyone is clear. So okay, does this makes it very clear that this is alkylation and this is acylation. Is this clear now? So when I say alkylation, I need somebody who can give me the CH3, correct? I need someone to give me a CH3. So that CH3 is, who's my reagent then? CH3Cl, and I need my AlCl3 catalyst. Khalas, finished. Then my catalyst still remains the same, but so I need my someone to give. So this is alkylation. Now I need acylation. To get acylation, I need someone to give me that. That's my RCO. Okay, let's make it very clear. That is RCO. Or maybe you can write it this way, COR. Okay, got the idea now? You see the difference? So what do I need? My reagent has to be, just put a Cl next to it. So just write CH3CO and just stick a Cl to it. Khalas, finished, done. Now tell me if it makes sense to you. That bit, that's my reagent there. Questions, please, now. I hope this is very clear. That's the difference between alkylation and acylation. Both of them are electrophilic substitution given by Friedel. Guys, on a scale of 0 to 10, where do you stand now?